Okay, let's be honest. Have you ever looked at a giant pile of Legos and just wished it would sort itself? Well, today, we're going to explore how you could actually teach a computer to do exactly that. We're going to pull back the curtain on how some of this powerful AI really works, and we'll use everybody's favorite building bricks to guide us through it.
So here's the big question, right? Could a computer actually learn to sort a pile of Legos? I mean, it seems simple enough for us. You and I can spot the difference between a 2x4 brick and a little 1x1 tile in like a split second. But for a computer, a picture is just a bunch of numbers in a grid. So how in the world do you teach it to see the difference? That's really the core challenge we're going to dig into.
All right, to solve this puzzle, we're going to build what you could call a smart sorter. And this project throws us right into the world of something called image classification. Now that might sound super technical, but it's really just a fancy way of saying we're teaching a machine to figure out what it's looking at in a picture.
So here's the mission, plain and simple. We're going to feed our machine hundreds and hundreds of pictures of different Lego bricks. And the goal is to get it to learn how to tell them apart, completely on its own. And that's the key here, no manual rules. We're not telling it, look for 4 dots or look for a rectangle. Nope, this is all about the AI learning directly from the data itself.
So how exactly do we teach a computer to see? Well, you've got to give it a brain. Not a human brain, obviously, but a digital one. And this digital brain is called a neural network. Think of it as the engine that's going to power this whole entire project.
So what is a neural network? Well, at its core, it's a system that's actually inspired by how our own brains learn. It's made up of all these interconnected digital neurons. And the cool part is, after you show it enough examples, it starts to recognize patterns all by itself. You know, things like the difference between the shape of a square brick and a long rectangular one.
Okay, let's really break down how this digital brain sees. It's kind of like a 3-step process. First, you have the input layer. Think of this as the eyes. It just takes in all the raw pixel data from the photo of the Lego. Then you have the hidden layers. This is the real brain of the operation. This is where the magic happens. The first few layers might spot really simple stuff, like edges or a splash of red. But then deeper layers start to combine those simple things to recognize corners or curves, and eventually the full shape of the brick. It builds up its understanding step by step. And finally, you get to the output layer. This is where the brain makes its final decision and tells us something like, okay, I'm 95% sure that's a 2x2 brick. All right, so we've got the theory down. Now, let's get into how this thing is actually built. You know, in the real world. It's kind of like the AI's training montage scene in a movie. This is where we take our digital brain from a total blank slate and turn it into a Lego sorting expert.
So building this brain really comes down to 3 main steps. First up, you need the study materials, the actual data it's going to learn from. Step 2, you have to design the brain structure, the architecture. And finally, step 3, you kick off the study session and let the training process begin.
So, what exactly are these study materials? Well, in this case, it's a data set of 600 photos. And here's the important part. Each Lego brick in every photo has been carefully labeled. This labeled data is absolutely crucial. It's the only way the AI learns to connect a certain pattern of pixels with a name, like 2x2 flat tile.
And what about the brain structure? For this project, we're using something called a feed-forward neural network. All that means is that information flows in one direction, from the input through the middle layers to the output. And it's built using some really popular AI tools called TensorFlow and Kera. You can think of them as the go-to programming languages and toolkits for building these kinds of AI models. Okay, so after all that training, it's finally time for the final exam. We've built the brain, we fed it hundreds of examples, but did it actually learn anything useful? Let's find out. We're going to see how well it does on a test with a bunch of Lego bricks it has never, ever seen before. And the results are in. We're looking at an accuracy of around 90%. Wow, that is seriously impressive. I mean, think about it for a second. After looking at just 600 photos, our little digital brain learned to identify these Legos with a really high degree of success. Now, to put that 90% number into perspective, what that really means is, if you showed our AI 10 totally new Lego bricks it's never seen, it would get 9 of them right. That's a solid A on its final exam, for sure.
And this is such a cool look into how the AI actually thinks. See, it doesn't just spit out a simple yes or no answer, it gives a confidence score. So for this particular brick, it's saying, hey, I'm super confident it's this one. But it's also considering other options, just with a lot less certainty. It's making a really sophisticated, educated guess, which is, a lot like what we do.
Look, sorting Legos is a fantastic start. It's a lot of fun. But this is where the story gets really exciting. Because this little project is actually a miniature version of the exact same AI technology that is out there solving some of the world's most complex problems.
I mean, these same principles scale up dramatically. Sure, you could build an actual Lego sorting robot, and people do. But this exact same technology is used to spot tiny microscopic defects on factory assembly lines, to manage inventory on retail shelves, to create new learning tools for schools, and even to help doctors identify diseases in X-rays and MRIs. The core concept? It's identical.
And really, that's the key takeaway here. What we just explored with a simple little Lego brick, that's actually a fundamental building block for huge innovation. Understanding these core ideas is the very first step toward creating intelligent systems that can go on to tackle massive, real-world challenges. So, what's the big picture here? It's a great reminder that even the most complex, mind-blowing intelligence systems out there are often built from simple, easy-to-understand pieces. Just like Legos, right? It all starts one brick at a time.